I am so glad you convinced me that the family car should be the Defender 110. It is so beautiful inside, it's so comfortable, and it just feels indestructible.
Yes, it really is. I've been waiting a long time for the new model to come out. The Defender 110, I'm telling you, it's my favorite car of all times. It's my third one. You know, I have stories of going off road. The guy managed the group. He was like, "What are you doing in this beautiful car?" I'm like, "I'm going off road." He's like, "Are you sure? Because you can use one of ours." And then they look like Mad Max cars. I'm like, "No, no, 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 we're going to do this." And he was shocked.
Wow. Well, it's great because the Defender has been reimagined for 21st century adventure, and its unparalleled off-road ability as well as its robust interior are invaluable whether you're headed towards uncharted territory or just a weekend of exploration. The Defender 110 tackles challenging surroundings with absolute confidence. The SUV conveys strength outside and in, featuring peerless technology like an intuitive driver display and an award-winning infotainment system. That's my favorite part, to keep you connected no matter where the journey takes you. Adventure is unique to everyone, and so is the Defender. Choose from the two-door Defender 90, the four-door Defender 110, or the larger Defender 130 with the ability to seat up to 8 passengers. You'll find uncompromising performance in all three. So pack up and go even further with the Defender 110. Learn more at LandRoverUSA.com/Defender.
This isn't your average business podcast, and he's not your average host. This is the James Altucher Show. Today on the James Altucher Show.
In part one of this, Scott Gottlieb, former FDA commissioner, also wrote the book, just came out, Uncontrolled Spread, Why COVID-19 Crushed Us and How We Can Defeat the Next Pandemic. It is the Bible of every piece of information you ever wanted to know about COVID, drugs, vaccines, the FDA, our response, the economic lockdowns. He answered a lot of my questions in part one. Part two covers more of the vaccines, immunity, and more FDA questions. Since he was the FDA commissioner, I was really curious why we need, if I have a terminal disease, why do I have to wait years and years and years and billions of dollars to be spent for a drug that I think might save my life? And he was gracious enough to answer that question as well. So here's part two. Part one is released the same day as today. Knock yourself out. Is there a danger with the vaccine kind of simulating the chronic infection process? So someone has COVID, then 6 months later they get the vaccine. By this time, their body's like, I've dealt with this before. And the virus says, I've met this person before. And things start to happen. Because and again, this is not vax or anti-vax or anything. I'm just curious, are there dangers in terms of mutations with the vaccines?
Yeah, no, it's a good question, and this is and that very question is why a lot of people were against the idea of only partially vaccinating people. So if you remember the whole debate that went on, and England went down this road, where they gave one dose to people and they withheld the second dose to try to extend the supply. Part of the argument against doing that was that if we just partially vaccinate a whole bunch of people and they have partial immunity, they're going to be more prone to developing an infection that they don't get really sick from it, but they can't clear it either. And now they become chronically infected. And that was part of the reason. So, you do create a circumstance where if you have people who are partially immunized, but not really fully protected. So immunocompromised people, and that's part of the reason that we're delivering booster shots to the immunocompromised. You could theoretically create the circumstance where you get more escape. And that's why, there's a presumption that we're going to have to update these vaccines over time, that the virus will evolve slowly over time, and we'll need to have new vaccines in the future. One of the debates going on right now, and there's no consensus on this yet. There's actually even no process for reaching a consensus. We're going to need to develop some kind of global process for coming to a consensus around what the next vaccine is going to look like we have for flu. But, the debate going on right now is, if we're going to fashion a new vaccine, should we do it off of the Delta backbone and make an assumption that the next variant that threatens us is going to be within the Delta lineage? And that's a debate going on right now in virology circles. I'm on the board of Pfizer, as you know. Pfizer, Moderna, all the companies are developing Delta variant vaccines, not necessarily because there's an assumption we're going to need to use it, but you want to have it in your back pocket. So every time a new variant comes along, the vaccine manufacturers develop at least the starting point for making a vaccine against that new variant, so that we're ready to go if something does really pop.
And just in case the variant is not cured by the original vaccine.
Just in case the original vaccine doesn't cover the new variant well. I mean, remember, we're using a vaccine right now, and it's fortunate that it's still effective in this setting, but we're using a vaccine right now that's sort of, 2 generations removed from the original virus on which it was designed. It was designed against the Wuhan variant. We had the Wuhan variant, then we had B117 become epidemic around the world. Now we're on to Delta. So we're a couple of generations of this virus removed from the variant on which this vaccine was premised, and the vaccines are still very effective, and still very
against
protective.
Delta. You mean it's still potentially
against Delta, right? It's still providing protection against Delta, even though it was fashioned against a very different variant.
Now, what about vaccines versus drugs? So remdesivir was used early on. I think when the president had COVID, he used Regeneron or some cocktail of drugs. I had COVID. I didn't use anything. The doctor just told me to use Tylenol. What's the deal? If you're not in the demographic that's gonna maybe die from this, but you're still very sick, how come we're not using more drugs or figuring out what drugs could alleviate symptoms and help you survive?
Yeah, because we don't have them. I mean, what we've been doing to date is trying to repurpose existing drugs for the treatment of COVID. We found some that are effective for treating the sort of symptoms of COVID, like steroids in the setting of people who have severe disease. The antibodies were the first line of defense, the first drugs that we were able to scale. There was always a presumption that antibodies would be the first line of defense against a novel virus. We had plenty of precedent for that, yet we still weren't in a position to mass produce them in the way we should have been. And even now, there's shortages of the antibodies. The Biden administration
What is an antibody medicine? I don't understand. What is that?
So an antibody, the Regeneron drug is an antibody-based drug, or Lilly's drug is an antibody-based drug. And what it basically is when you get vaccinated, the vaccine stimulates your body to make antibodies against the virus. Those antibodies bind to the virus. They're taught to recognize the virus. They bind to the virus. And once they bind to the virus, it triggers your other immune cells to then clear the virus from your system. And that's how you fight a disease. The antibody drugs are basically the same premise. And rather than stimulating your body to make those antibodies, you're basically infusing them. So you're taking an intact immune system, putting it in a bottle, and infusing it into a person. So you're basically giving them an intact immune system. We have very good technology for making fully human antibodies using recombinant technology. Regeneron's expert in this, Lilly is, there's dozens and dozens of other companies that do this. And we knew that this was a very good approach, a very good early approach to trying to combat a novel virus. We had fashioned a therapeutic antibody that's effective against Ebola. We had fashioned one that was effective against MERS. And we fashioned one that's very effective. We fashioned more than one. Vir has one, Lilly, Regeneron, that are very effective against SARS-CoV-2. The problem is we just can't make enough of them. So we didn't have the capacity in the US. Nobody had sort of thought about how do we create an available capacity to be able to scale the manufacture of an antibody in a crisis like this. The other drug that could be available, to your point, is a drug like a Tamiflu for COVID, a drug that you take it as a pill, and it inhibits viral replication. So it basically blocks the virus from being able to replicate and helps prevent the onset of severe disease, or helps treat disease and prevent progression of disease, a lot like we use Tamiflu for influenza. There's companies working on that, including Pfizer, where I'm involved. Pfizer has one in advanced development. It's a protease inhibitor. Merck has one that looks very promising that's in advanced development. Roche has one that's a little bit further behind. Any one of these drugs could end up working. And if not, I think another drug will. I think this is what we call a druggable target. This coronavirus it's not like HIV, where it's such a complex virus in terms of how it replicates that it's going to be very hard to make effective drugs that block viral replication. This coronavirus replicates through mechanisms that we have become accustomed to developing drugs against in other contexts. So we should be able to figure this out. We will, in my view, we will eventually have a pill that's safe and effective that you can take to help prevent onset of disease in people who are diagnosed early. And whether it's one of the current drugs in development or something that gets developed 6 months from now, that's in early development now that we're not paying attention to, I think something's going to come along. And that's going to dramatically change the landscape, because then when people get diagnosed, there'll be an incentive to get diagnosed early, because there'll be a drug you could take that hopefully will substantially reduce your risk of having progressive symptoms and developing severe disease and getting really sick.
So in the so A, why didn't we do that already? Like why are vaccines easier to make than these drugs, or what's, because that would have been great to take one of these drugs as soon as I got it. Like that was the worst 20 days of my life because there was no drug.
Yeah, it's a good question. In some respects, the technology for developing the vaccines that we used in this instance, using fully synthetic constructs to develop a vaccine using just the genomic information. So we were at a technological inflection point where we were able to derive these vaccine constructs using fully synthetic tools. In some respects, that allowed us to come up with vaccine constructs more quickly than screening drugs against these novel viral targets. And so the drug making process, we're relying on older technology right now. I think the next generation of drugs that are put into development will rely on newer technology. And so you're going to see more novelty. But the first generation of drugs, what we were doing and what we're still doing really is kind of repurposing antivirals that we had already developed for other purposes, or antiviral constructs that we had developed for other purposes against coronavirus. But it is a longer process. And also, if you want to develop a drug that prevents progression of symptoms, or can be used as a prophylaxis, where if you're exposed to COVID, you can take a drug and it prevents you from getting COVID. Doing those trials is hard, and it's gotten even more difficult, because if you're trying to prove that the drug prevents progression of symptoms, the reality is most people don't progress. Most people who get COVID don't have progressive symptoms. They do well. And in a population that's now heavily vaccinated or heavily exposed to COVID, running a clinical trial to prove that a drug prevents progression to severe disease is going to be very hard. And I think that's why you're going to see the clinical development process for drugs go more slowly going forward, because at least running the trials here in the US are going to be difficult, because 76% of adults over the age of 18 have had at least one dose of vaccine. And of the remaining 24% of the population, probably half of them already had COVID. So there's not a big pool of people who don't have some level of immunity against COVID at this point.
How long does immunity last, whether it's from getting it or getting a vaccine?
Yeah, the short answer is we don't know, and we don't understand long-term immunity in the setting of SARS-CoV-2 because we haven't been studying it long enough. The assumption is that it's going to sit somewhere in between seasonal coronavirus and SARS and MERS. With SARS and MERS, SARS-1 and MERS, people developed a very durable immunity. People got very sick from it, and they developed immunity that lasted years, and in some cases, a decade or more. With a seasonal coronavirus, the immunity you get from a seasonal coronavirus only lasts sometimes a year. That's why we keep getting reinfected with coronaviruses. There's an assumption that this is going to sit somewhere in the middle, that the immunity is going to persist longer than a year, but not 10 years. But we don't understand the answer to that question. We certainly don't know the answer to that question in the setting of naturally acquired immunity, because we're doing a poor job of studying people who've been naturally infected in perpetuity. We have a better sense of how long the immunity lasts from vaccination, because we're actually studying that very carefully. But what we don't know is how long is the immunity going to last from vaccination if we give a booster. The first two doses of the vaccine were given very closely together, 3 weeks apart in the case of Pfizer, 4 weeks apart in the case of Moderna. And one of the prices you might pay for having given those doses so closely together is the durability wasn't as long, that the second dose wasn't sort of a true booster that induced long-term immune memory. And by giving a third dose, then you're going to induce longer-term immune memory. Now, we don't know. It's speculation, because we don't have the data, because we haven't followed people long enough. But the presumption is that, at least from natural infection, you're going to have a durable immunity. And from the vaccines, people do have a durable immunity, at least protection against severe disease and hospitalization, even if they see some declining immunity against any infection. And with a third booster, there's some reason to believe that you can extend the durability of that protection.
The future of learning is definitely online. Like, it's such
BS that you have to spend $200,000 or take $200,000 in loans and go to some fancy school when it's useless. It doesn't guarantee you a job. Most employers, including me, do not care about degrees or grades or anything like that. We want to care that you love what you're doing, that you know what you're doing, in some cases that you have experience or that you're willing to learn. But people in general love learning and are curious. Like the key to success is curiosity. And I think masterclass.com is the perfect model for online learning. I'm really happy they're sponsoring this episode. If you're going to give a gift, give the gift of learning. Masterclass makes a meaningful gift this season for you and anyone on your list because both of you can learn from the best to become your best, from leadership to effective communication to cooking. Let me tell you some of the classes I've taken. I've taken comedy from Steve Martin. I mean, can you believe I can take a class from Steve Martin on comedy, or Judd Apatow, my favorite comedy director? I could take an actual class from him on writing. Wolfgang Puck on cooking. Dan Brown on writing, or Judy Bloom, who's been on this podcast, on writing. By the way, Wolfgang Puck also has been on this podcast. It's such a pleasure. I try to take classes all the time from masterclass.com. And whether you're watching Masterclass on TV or listening in audio mode in the app or on their site, the quality speaks for itself. It's like these masterclass instructors are your own personal mentors that are going to help you reach the next level. How much would it cost to take one-on-one classes on comedy from Steve Martin or on chess from Gary Kasparov? You just wouldn't be able to do it. But it would cost hundreds of thousands of dollars. With a masterclass annual membership, it's $10 a month. Memberships start at $120 a year for unlimited access to one-on-one classes with all 180 plus masterclass instructors. So it's not just $120 for one instructor. You get all 180 plus masterclass instructors. Boost your confidence and find practical takeaways you can apply to your life and at work. And if you own a business or are a team leader, use Masterclass to empower and create future-ready employees and leaders. That's the real education in today's world. So this holiday season, you can give one annual membership and get one free at masterclass.com/JAS. JAS, of course, stands for the James Altucher Show. So right now you can get two memberships for the price of one at masterclass.com/JAS. Masterclass.com/JAS. Offer terms apply.
With vaccines, what's the data now? Like, so we've had the vaccines around for a while. Some people complain about vaccines. Most people are, you got to get a vaccine. You know, some cities are mandating vaccines or some companies are mandating vaccines. What's the actual data show now? It has COVID dramatically declined because of the rise in vaccine use. Like, how are there problems that were unexpected? Like, what's the final word, if there is one, or close to the final word on vaccines, on these vaccines?
I think the final word is these vaccines are safe and effective, and they've proved remarkably effective. 380 million Americans have the 380 million doses have been administered in the United States. There's been 5.8 billion people vaccines delivered globally. Not all of them are the same vaccines, obviously used in the U.S., but there's been a lot of people who've been vaccinated against COVID at this point, and so you have a very large data set. You have an enormous data set, and you have that data set over a prolonged period of time. I mean, there's people who, were vaccinated 2 years ago in the clinical trials. So you have a very robust data set to demonstrate the performance of these vaccines, not just their efficacy, but their safety. And what we're seeing in the United States is the vast majority of people who are developing severe disease, and certainly the vast majority of people being hospitalized and getting very sick, are people who are unvaccinated. More than 90% of the hospitalizations are among unvaccinated individuals. And even though a lot of people in the US are vaccinated, there's still on an absolute basis a lot of people who aren't. And Delta is so contagious that it's finding its way into pockets of vulnerability. And what you have also is a situation where the unvaccinated aren't sort of dispersed sporadically through society. There's certain social and geographic compartments where you have a higher clustering of people who are unvaccinated because they've chosen to go unvaccinated. They're in hard to reach communities. They're in underserved communities. And so Delta finds its way into those pockets of vulnerability and ends up infecting people because it's so contagious. One of the most contagious respiratory viruses we know of. So the vast majority of people who are being affected by this Delta wave are the unvaccinated. The vaccines are largely doing their job in protecting people who got fully vaccinated.
And so in the future, as you point out in the book, we're going to have a pandemic again, and it's not going to be related to SARS or COVID at all. It'll be something new that we're not ready for. And I don't think the world can afford another lockdown again. Like, it's not like there's a quadrillion dollars ready to spend every time we get sick. Like, and you offer solutions. What should we do better next time?
Well, we need to have an agency capable of sort of surfacing this information on a real time basis and better informing the response. We need to have the capacities to scale the response, deploy diagnostic tests at scale, manufacture antibodies at scale. So we need to think about how we build those capacities and keep them hot, keep them ready. We can't just create what we used to call a warm base where you build a whole bunch of infrastructure and mothball it because it's not ready when you need it. You have to keep it operating. I also think we need to think differently about how we gather information abroad. We can't rely on the good graces of other nations to inform us when they're host to an emerging infection because countries don't do that. China didn't do it in this instance, and we have repeated episodes in history where countries concealed information. And if anything, COVID conditioned countries to be even less forthcoming because when the British raised their hand and said, we have this concerning new variant called B117 that seems to be much more contagious, what's the first thing the French did? They closed the channel. So now any country looks at that and they said, if we notify the world that we have an outbreak of a new variant or a new virus, everyone's going to isolate us. So what that means is we need to get our tools of national security more engaged in this mission. We're going to need to figure out how to gather the information, not just rely on people to give it to us willingly. We've always relied on, multilateral agreements and public health authorities to operate globally, and public health agencies never wanted our tools of national security and our foreign intelligence agencies anywhere near this mission. I don't think we can afford that luxury anymore. Every other country is gathering this information. We now know there was information that was obtainable, certainly by mid-December and probably earlier than that, inside China, if we were looking, that would have tipped us off to the fact that they had a novel coronavirus, that there was asymptomatic transmission, that there was human-to-human transmission. We now know there were dozens of samples sent off for sequencing by mid-December, and probably earlier than that. We just know about the ones in mid-December. That's what's been publicly reported. Any one of those was electronic information that could have been intercepted. So there was information to be had that could have informed us of what was going on. And in the hands of a competent political response, that could have been a 4-week head start on really understanding the gravity of the situation that this virus posed, and certainly a 2-week head start. I mean, 2 weeks would have been easy. 4 weeks was possible. And as it were, we had to wait for China to finally divulge this information by mid-January that we started to learn about the true severity. And at that point, it was out of control.
So with a 2-month head start, you're saying we could have done a lot more testing. We could have started the vaccine process or the drug process much earlier on. We might not have had to, now in retrospect, we maybe could have used metrics to determine lockdowns, like, okay, a certain number of cases or, whatever, instead of saying the entire country has to lock down. There's so many more questions I have, actually, but I recommend people read the book. It really is the Bible of what happened, when it happened, all the data. It answers all the questions people argue about every day on social media in various conspiracy theory threads or whatever. I have one more question, which is a more generic FDA question. You were the head of the FDA, and I've been meaning to ask someone who has been the head of the FDA this question. If I have cancer, this has nothing to do with COVID. If I have cancer, or if someone has cancer and a cancer drug that looks interesting passes phase 2, so it's roughly safe for humans, I think that's phase 2. Why can't I choose to take it? Why do I have to wait another 10 years and a $2 billion spent for phase 4 to happen?
Well, look, there are mechanisms to provide drugs earlier to patients while they're still in clinical development. Expanded access is a mechanism that the agency operationalizes to make it easier for patients to get access to drugs that are still quote unquote experimental and aren't fully approved yet. In many cases, the reason why the drug isn't made available is because the companies don't make them available. And in many cases, the companies don't make it available because they argue, well, if we make it available outside of a clinical trial, we're not going to be able to enroll our clinical trial. People, if they can get it outside the trial, why would they enroll in our trial? And part of that is because we still do in certain settings, and this isn't true in oncology anymore. In oncology, we said we're not doing this anymore, but we still do placebo trials where we say to enter the clinical trial, you're going to be randomized to either get the drug or get a placebo. And if people look at that and they say, okay, I can get the drug through expanded access and I know I'm getting the drug, or I can enter the clinical trial and I'm either going to get the drug or get a placebo, they say, I'm not entering the trial. I'm going to use expanded access. And so companies don't offer expanded access because they worry that it will disincentivize people from entering that trial. Now, I think it's unethical in the setting of a disease that we know is terminal to randomize patients to a placebo pill. And in oncology, when I was at the agency, we stood up and said, we're not, except in very select circumstances, in the setting of cancer, we're not going to do placebo trials anymore. We're going to use open label studies or use historical controls where we compare patients to historical patients where we know what the outcome was, rather than randomizing patients to placebo. And if you go down that route, I think that is going to open up more opportunities to both have the clinical trial and have the expanded access available side by side in the setting of oncology.
But why even have a stage 3 or stage 4? Like, just let me choose, and then the data will show from population data. So it's not a scientifically controlled experiment. It's another way of gathering data. Time will tell that this drug works or doesn't work.
Well, look, this is where there's a vigorous debate going on. You see people on the other side of this question arguing strenuously that we're too permissive, that we're approving drugs on the basis of clinical trial data that isn't rigorous enough. And not only should we have a phase 3, but we should have a really large phase 3. And there's a really robust debate going on constantly. I mean, we were at FDA constantly in the middle of this discussion where there were people on both sides of it. I think that we are slowly evolving towards a recognition that empiric evidence isn't the only form of evidence, that the old model of the frequentist approach, we have a randomized trial and you try to control all the variables except for the one that you're trying to study. Does the patient live longer or not with the drug? In an age when you can collect very large data sets and we have computational tools for controlling for the variables in those data sets, and we've gotten really good at collecting and analyzing data computationally, you don't need to design the perfect experiment to be able to isolate for the question you're trying to answer. I mean, investors use large data sets all the time, and economists, and derive pretty accurate answers off those data sets. We are starting to migrate that into healthcare, and I think we're starting to gain more acceptance around it, but it still is controversial. There still is a large group of people who say that there's nothing that could be as certain as the old frequentist approach, and we're never going to be able to substitute real-world data for that. My argument would be that might be true now, but the data sets are getting so robust, our ability to collect data is getting so robust, and our ability to analyze it using computational tools is getting so sophisticated that there will be a time when that could give you an answer more efficiently and maybe with more accuracy than a carefully controlled experiment. I mean, we've got to allow for that because the tools are getting better.
Well, thank you so much. I've been dying to ask that question for like a decade, so thank you for answering that. Scott Gottlieb, author of, former FDA commissioner, first and foremost, and then the author of a great new book, Uncontrolled Spread, Why COVID-19 Crushed Us and How We Can Defeat the Next Pandemic. This, for me right now, is the Bible of what happened, when it happened, why it happened, and what's going to happen next. And I really appreciate you writing that book and coming on the podcast.
Thanks a lot. Thanks for having me.
These days, we're all investors, trying to be smart with our money despite our worst impulses. But at iShares, we believe that deep down inside of every investor is a better investor. One that's just waiting to be let out. Explore iShares ETFs and insights and let your best investor out. Visit iShares.com for more information.